Okay, now let's continue on for the second of three narrations that I have mainly about methods and why we do psychological science. Where we left off last time was with correlational research, and I want to look a little more about. We talked about types of research methodologies that can be used for descriptive and correlational studies. Now let's look at what we mean by correlations. Correlations involve looking for associations. So the goal in correlational research, and really in any kind of research, is to learn about the relationship between variables. How similar or distinct are two different variables? How well does one variable predict another variable? So when we do correlations, there are statistical techniques that allow us to, when we get scores from various people on one variable, by the way, a variable is something that varies, okay, something we measure that can vary and differs. So if we get scores on one variable from a number of individuals, and we also measure the same individuals on a second variable, and we get the scores on that, we can see the extent to which they're correlated or related. And one statistical procedure leads us to a bottom line known as a correlation coefficient, which is a statistic used to measure the strength and direction of the relationship between two variables, commonly referred to as, it's referred to by the statistical symbol R. Okay, R refers to a correlation coefficient. Now, we don't need to get into the details about a correlation coefficient, but what we should know a little bit about correlation coefficients is when you see a correlation coefficient, and you should know what it means, and basically how it is an indication of the strength and direction of the relationship between the variables. So, we'll get into different kinds of correlation, but what we'll learn is that R is a statistic that can vary from -1, which indicates a perfect negative correlation, through 0, which indicates that there's no relationship between the variables, a zero correlation, through a +1, which would be a perfect positive correlation. So what is a positive and what is a negative correlation? Well, positive correlation is when two variables move or vary in the same direction, okay, either up or down. So higher scores on variable A, as scores on variable A are higher, scores on variable B are also high, okay. Lower scores on A are associated with lower scores on B. So they're varying in the same direction. It's a positive, also known as a direct correlation. A negative correlation is basically when two variables move in the opposite direction. Okay, as variable A increases, variable B decreases. High scores on variable A tend to be associated with low scores on variable B. High scores on variable B tend to be associated with low scores on variable A. I'm sorry. And then a zero correlation is when, knowing the score, that the score on variable A bears no relation to the score on variable B. If it's a high score on A, the score can be high or low or in the middle on B. It's a low score on A, same thing. No relationship between the two variables. When one increases, the other one can increase, decrease, stay the same. Okay. So the correlation coefficient, getting back to that, remember it's a number representing the strength and direction of correlation. So the strength of a relationship really refers to how close the dots are to a straight line. The dots on a what's called a scatter plot. Okay, Um, so if they tend to correspond, the closer they tend to correspond to a straight line, the stronger the relationship is. Okay, to the point where if there is no scatter, the dots are really all line up in a straight line, that would be a positive correlation if the line's going from low, low to high, high, and a negative perfect correlation if it's going the other way. So, for example, okay, and the direction of a correlation is indicated by the symbol positive or negative. Positive correlation, there's a positive symbol in front of the R. Negative, there's a negative symbol. So, okay, guess the correlation coefficients. R equals +1. Okay, so as you can see, this would be a perfect correlation. We'll call this variable A. Okay, this is variable B. Okay, and each dot represents the point. Okay, so if we move over here, this is the score that that person got on variable B. This is the score that they got on variable A. So the dot is the coordinate of the two scores. So if all the points fall in a straight line, you can see that in lockstep, you know, and in a perfect way, as scores on variable A increase, go this way, scores on variable B decrease in this perfect linear fashion. And so the correlation coefficient, that number crunching, would lead to an R correlation of +1. Okay. Now here's an equally strong, so a very strong, perfect correlation that's positive. Here's an equally strong correlation, but it's negative. Okay. So everything moves in lockstep, but as we increase scores on A, variable A, scores on variable B are decreasing. So the line's going from upper left to lower right. It's a perfect negative correlation. Okay, and here's a scatter plot that indicates no relationship at all. You can see that there's no systematic relationship among these variables. Okay, so the R, we crunch the numbers, we'd get a correlation close to 0. So, as I said, now, here's some examples of correlations. So scatter plots are, very few relationships are perfect, right? Okay, so there's going to be some variation, okay? And so the strength of a relationship would be indicated by how much spread there is around that straight line that we draw through this ellipse, okay? So here's a modest, pretty good correlation, but it's not a perfect one, between salary, okay, and years of education. And as you can see, as salary increases, okay, so too does years of education. So the more education a person has in general, the higher the salary. Okay, but it's not perfect. Okay, here's a person with, right here with, quite a bit of, let's see, here's a person with, for example, looking for a good example, with quite a bit of education, okay, not that much of a salary. It's off the beaten path, but nevertheless, taken as a whole, the relationship is a positive one. This might come to a correlation of maybe 0.5, okay, 0.5, positive 0.5 because it's positive. There's a negative correlation, okay, so in a face-to-face class, unlike our online class that I may be speaking to you about now, okay, we often find that as the number of class absences increase, okay, we measure this in the students, in a lot of students, okay, the exam scores tend to decrease. So the greater the absences, as you can see, the lower the test scores, okay. That's not a perfect correlation, but it's definitely a negative correlation. And here's the correlation. Here's what the scatter plot might look like, with each dot representing a person's shoe size and their score on an intelligence test. And you can see there's not a whole lot of relationship here between shoe size. There's no relationship between how big your feet are and your intelligence, okay? Unless we're going across age, right? Okay, so little kids might not be quite as intelligent yet and has lower shoe size. So here we'll stick with adults. We find no correlation. Got it? All right. So correlational research involves going out and measuring people on two different variables, okay, and then scoring them, and then computing the correlation and finding out if the variables are positively, negatively, or not correlated. So correlational research, okay, typically done with field studies, naturalistic observation, surveys, archival research, things like that. There's a lot of advantages to doing correlational research like that. You can study the associations of naturally occurring variables, that we don't go in and we try to change or manipulate or induce these variables. We're looking at them in their naturally occurring state, okay? So we can go out there in the field and measure things that we couldn't bring under control, for example, in a laboratory. We can examine phenomena that are difficult or unethical to create for research purposes. Okay, we can go out there and look at how people, for example, have reacted to maybe a tragedy, a hurricane, some tragic event, and measure them on various variables and see if there's a relationship between the degree of loss they had and how much grieving they're doing, or the extent to which people have been able to cope, and look at relationships there. We wouldn't be able to study that under more controlled circumstances. We couldn't do an experiment and create a tragedy for some people and not for others, and then look at the relationships. That would be difficult to do, a difficult situation to create. Okay, but with correlational research, we can go out and measure these things in the natural occurring phenomena. So, relatedly, there is this freedom in settings in which the variables are measured. But there's one very serious disadvantage of correlational research. Okay, and some of you probably already know what this is, and it's a big disadvantage. Correlation is not causation. Okay, just because we know variables are related from a correlational study, we can't make conclusions, okay, about which variable is the cause, which variable is the effect, whether either one is the cause, or anything about causation. Okay, all we know is the variables are related, not where the source of the relationship comes from. So, correlation is not causation. So, let's look at some correlations. People who floss more regularly have less risk of heart disease. This is true. There is a correlation, if other things being equal. Okay, if you measure people, survey them about how often they floss, and record whether or not they have experienced heart disease, you will find a negative correlation. Okay, that is, as flossing increases, okay, higher levels of flossing are associated with lower levels of heart disease. Correlation. Okay, so if this is from a survey, okay, can we really conclude that flossing prevents heart disease, so that it's the cause? Okay, or could it just be the opposite, that people that have heart health, or not the opposite, but there is a third variable going on here, that, well, you've got, some people just have these very heart healthy habits. They do things that keep their heart healthy. They also tend to be people who floss regularly. Okay, so flossing doesn't really have any causal relationship at all with heart disease necessarily. Okay, it could be that it's just that, people who have healthy habits, that relates to their heart and to their teeth. Okay, and their habits with regard to those. We can't really infer cause and effect just from doing a survey where we gather these data from people. People with bigger feet tend to be taller. Okay, now of course there's an absurdity there. You wouldn't conclude from this pretty good positive correlation: the bigger the feet, the taller the person. The taller the person, the bigger the feet. Okay, that big feet cause people to become taller, right? Okay, or that being tall somehow causes you to have big feet. Okay, no, bigger feet doesn't cause height. Okay, what's going on is a third variable having to do with, just basically people's size in general. Okay, so let's, if we go back to our textbook, okay, in this course, let's think critically about some examples that are given in the text. One involves self-esteem, okay? So if a low self-esteem test score predicts a high depression score, what have we confirmed? Okay, so this is asking the question, suppose we observe a positive correlation, a negative correlation between self-esteem, okay, how good people feel about themselves, okay, how high esteem they hold themselves in, okay, and their level of depression. So the lower a person's self-esteem, the higher they score on some depression inventory, such as the Beck Depression Inventory or various other instruments that kind of assess level of depression. What does that correlation tell us? Does it tell us that low self-esteem causes or worsens depression? That depression is bad for self-esteem? You get depressed, your self-esteem goes down. So is it that self-esteem is the cause? Is depression the cause of self-esteem? Or could it be that low self-esteem is really part of the definition of depression, and we're really not connecting two different variables at all? That really low self-esteem is an aspect of depression, okay? Not a cause of it, not an effect of it, but part of it, okay? That could be true, okay? So there's lots of possibilities to be inferred, conceivably, by this correlation, okay? And we can't really tell, just from knowing that the variables are correlated, where the cause and effect, if any, is coming from. So, moving on with the same example, okay, self-esteem could cause depression, as we've seen. Depression could cause low self-esteem. And a third possibility that we didn't consider, we considered another third possibility, but here's another third possibility. Call it a fourth possibility. So one experiences depressing events, okay, or one is biologically predisposed, okay. We're kind of like predisposed. Some people are predisposed to be have certain kind of affective responses to life, if you will. So it could be that that people that experience highly distressing events in which they feel somewhat responsible, let's say, or people who have a biological predisposition going in a certain direction, that these variables, which we call third variables, okay, that for example, distressing events could cause low self-esteem and could cause depression. So there's no relationship really, cause-effect going on here, okay? But both variables are moved by a third variable in the in the in a direction that looks as though that creates the correlation. This drives low self-esteem. This drives high depression. We get a negative correlation. The third variable driving both of the others. Okay, so we could call this the which causes which problem, and this we could call the third variable problem. And those are the two big problems with correlational studies, purely correlational studies. One of my favorite examples over the years derives from a magazine article I read many years ago, actually while I was in the pediatrician's office with my small daughter, and we were waiting to be seen, and they have the magazines out in the waiting room. And I picked up a Red Book magazine, okay, and there was this article that the journalist, some journalist had written, where he was tackling the question of, this was in the 70s, by the way, of the relationship between sex and marital happiness. Okay, so he wrote this article where he was citing surveys and various kinds of studies done in psychology and in sociology and health and things like that, in which couples were surveyed, okay, in a number of studies with regard to how frequently they had sex. Okay, these married couples. Okay, whoops, what happened here? How can I go back here? Whoops, there we go. Sorry about that. My finger's trigger happy. So what these surveys were showing were that married couples that reported having quite a bit of sex, a high amount of sex, okay, were also reported greater marital happiness. Okay, those who had less sex, okay, were tended to report less marital happiness. So I went through all these studies and what the psychiatrists and psychologists had to say about it, and so on. And he concluded in this article in this magazine that that one solution, okay, to marital problems and marital unhappiness and discord, okay, might be to have more sex, okay, that the couple should have more sex, okay. So what was he inferring from the surveys that showed this positive correlation between amount of sex and amount of happiness in a marriage? Okay, he was concluding that the sex was causing the happiness. Okay, a lot of people tend to agree that sex could conceivably cause happiness. Okay, but can one conclude that from this survey? Well, I think if you think about it, you might say, well, maybe not so much. Okay, yes, it could be that having more sex leads married couples to be happier with each other. But couldn't it be the other way around? That happy couples that are happy with each other, are more likely to kind of, get together, okay, and have sex. Okay, they're happy with each other, they hang out, they have more sex. So maybe happiness causes sex. Maybe sex causes happiness. We can't tell which is which. Maybe both are true. Okay. It's also possible that neither is true. Okay. Maybe there are third variable issues going on here. Okay. So for example, this was in the 70s. Lots of young couples were this kind of a new things. Dual career couples. Okay, the feminism was on the rise. Okay, a lot of more equality, men and women going out and having careers, and there was a lot of that around, and it was the movement. Okay, so you had situations where you had many couples that each were kind of pursuing their own careers and out a lot and doing, working a lot, and different hours and so on, so that some may have had a hard time spending time together. Okay, and that might have been a source of both unhappiness in the marriage and also a source of a low level of sex, because after all, you got to sort of be together in order to have sex. I mean, I guess they had phone sex back in those days. We didn't have Skype, wasn't around, but you get the point. The point is that you have to be together to sort of have sex, okay? And not being together makes for less sex. Not being together may make for less happiness, okay? On the other hand, if you're spending a lot of time together, you can have a lot of sex, and you might be happier as a result of being able to spend time together. So it could be that this third variable, amount of time spent together, could be causing both the amount of sex and the amount of happiness, moving them in the same directions so that they were positively correlated. More sex, more happiness. So it could be sex causes happiness, happiness causes sex. A third variable, like time spent together, causes both, and so they're correlated. In all likelihood, maybe all three have some element of truth, but we don't know just by having the correlation. So if you want to explain the conundrum of just knowing that there is a correlated, maybe a good example is to give people the sex and happiness one. So that's the problem with correlational studies. Okay, we can't infer cause and effect. Now, sometimes you can't do any better than correlational studies. And there are ways to do correlational studies, or a number of correlational studies that help you, tease out, get a little bit of a handle on cause and effect. You can look for, order things by time. You can, pull out the influence statistically of other things that you measure. And there are various kinds of statistical modeling procedures and research design procedures that kind of help tease out some element of cause and effect from correlational research. Okay, but it never is complete. Okay, you never really can get the completely firm grasp on cause and effect. You can approximate it, but a mere correlation just doesn't get it done ordinarily. So we then get to the way to get to cause and effect is with an experiment. Okay, so let's talk a little bit about the experimental method, looking for cause and effect. So experiments are conducted specifically to examine cause and effect relationships. And there are two essential characteristics of all experiments. Okay? One is control. The researcher in an experiment manipulates some variables, okay, brings them under his or her control, so that maybe some people get a lot of this variable, others get a little, okay? So you're manipulating that variable. That's going to be the variable you're going to think is going to be the cause. And then all the other variables, the possible third variables, or what are called confounding factors, okay? One attempts to control, okay, hold constant. And so in an experiment, the researcher exerts control over the variables. And the other essential characteristic of an experiment is random assignment to different treatment conditions. Okay, so that everybody that's available to be in an experiment has an equal chance of being in either, let's say, the experimental group or what we'll call the control group, or the variable, the group that gets a lot of the variable, the group that gets a little bit of the variable that's manipulated. Random assignment is essential because it's a form of control. Okay, it prevents the self-selection of people into an experiment. Okay. Now, if we just let people arbitrarily say, okay, you go in this group, you go in that group, and we didn't do this randomly, like pick numbers out of a hat and assign them to people, or use a random number tables or a computer-generated list of random numbers. If we just arbitrarily assigned, okay, we wouldn't know if something, if there were systematic differences, okay, in the groups that existed before the experiment began, and that could be a potential causal factor in our results. Okay, so random assignment is essential, and random assignment means that everybody in the population, available population, has an equal chance, okay, of being in one condition or the other. Okay, there's no self pre-selection. Okay, so if you're in an experiment that involves just two groups, the experimenter may literally, before you arrive, you're going to the next subject, flip a coin to decide what group you're going to be in. Okay, it's random. Very important. If we don't have random assignment, we don't have a true experiment. Key features of an experiment. Well, we have the independent variable. That's the factor that is manipulated, okay, that we're presuming is the causative one. And then there's the dependent variable. That's the factor that is measured, the variable that we're measuring, the effect. Okay. Notice that the term independent, in a sense, you can remember this, it's independent of anything that the subject, the participant in the study, the guinea pig in the study, if you will, does. Okay, it's manipulated. The experimenter does that. Okay, the dependent variable, that's what the subject, the participant, is dependent on his or her behavior. It's the factor that is measured. In a simple experiment, there is an experimental group that receives the treatment versus the control group that receives no treatment. And then third variables are controlled, they're called confounding factors, through random assignment and holding constant as many variables as possible. So let's look at the control group. If we manipulate a variable in an experimental group of people, and then we see an effect, how do we know the change wouldn't have happened anyway? We solve this problem by comparing this group to a control group, a group that is the same in every way except the one variable we are changing. So for example, two groups of children have ADHD. Only one group, okay, we randomly assign these children who have ADHD to one of two groups. One group stops eating the refined sugar. The other group is not so instructed and does not. Okay, that is our control group. Okay, so how do we make sure the control group is really identical in every way to the experimental group? That's random assignment. Okay. So, what I'm going to give is an example, okay, of an experiment that basically asks the question, are fast talkers more persuasive than slower talkers? Okay. Now, we're going to have a two-group design, okay, and in a sense, well, this is not, this is a two-group experiment, but one group will have the low amount, one other group will have a high amount, as opposed to a control with none and experimental with a lot. Okay. Now, there's some reason to think that fast talkers are more able to people who who speak fast are more able to persuade or to convince people of their point of view than people who talk slowly. Okay, this is actually a hypothesis, and there are a number of reasons for why that may be the case that we will actually get into a little bit later in terms of trying to figure out um, what the mechanism is between this relationship. But suppose we wanted to study this, okay? Well, I'm going to talk about this in my third narration on this topic, which is coming up very shortly. I had already prepared it, so but basically there's lots and lots of ways in which we could go out and study this, and I'll rehash this in the next narration. But we can see if there's a relationship with we can use correlational methods. We can go out and sample actual speeches, measure how fast the person's speaking, poll the audience for their agreement, make a scatter plot and compute the correlation between how fast the person was talking and the audience agreement ratings. Okay, and let's say we find that, oh wow, the speakers who spoke more quickly, actually their audience agreed with them more. Okay, so we have this relationship which seems to support the hypothesis, but here we've got some confusion about cause. Okay, well, is it that the speaker, that the speeches that the fast speaker gave were less complicated when they went in the fast speech and were more readily understood, and it's not the actual speed of the speech that caused the agreement? Is it possible that audiences sort of express their agreement in non-verbally and with applause and so on, and attention, and that it relaxed the speaker, and so the agreeable audiences caused the speaker to relax and be able to speak a little more fluidly and quickly without pauses and hesitations and uhs and that kind of thing. So maybe it was the audience agreement that was causing the faster speech. We don't know, just with this little correlational study. Okay, so we might want to do an experiment, and here it is. This is a two-group experiment. Okay, so we're starting with a population of participants, and through random assignment, we're going to randomly assign people to be either in sample A or sample B. Okay, and what we're going to do, we're going to present people in both groups with exactly the same message. Okay, and let's say the message was an audio presentation of a speech endorsing a policy that John Jay College should make mandatory passing a senior comprehensive exam, okay, in order for students to graduate a senior comprehensive exam in their major. Okay, pretty counterintuitive. That's something students would generally agree with. Okay, but strong arguments are developed for why that might be a good idea. We have a male speaker who is well trained to deliver this speech. Okay, and he is trained, and so we make two audio recordings. One in which the speaker presents the message. Maybe it's 10 arguments. The message maybe lasts like 7-8 minutes. Okay, and people listen to this and headphones, okay, endorsing senior comprehensive exams, okay. Students, the participants in this group, hear a speech that has been prepared and delivered slowly. The average speech rate is about 150, 155 words per minute. The speech is delivered at 120 words per minute, which might be something like I am talking right now. Okay. In this condition, exactly the same speech with exactly the same words is presented by the same male voice, okay, except that the speaker delivers the speech at 180 words per minute, above average, kind of fast speech, sort of like I'm talking now, with a little hesitation and really, putting it out there, okay? So that's the only thing that varies. We have the same experimenter given the same instructions, okay, asked to listen to the speech, okay, same conditions, same headphones, everything is the same. All the factors are held constant through random assignment. We have the same kinds of people in both conditions, assured for the most part by random assignment, okay, and so they hear the speech. After they hear the speech, they're asked a number of questions about the speech and about the issue. And one question is, to what extent do you agree with the speaker that there should be a senior comprehensive exam administered or that required for graduation at this college? Okay, so the participants in both conditions get the same measure. Okay, let's say it's a 15-point scale, and where 1 is completely disagree, 15 is completely agree. We get the data from everyone. We get the scores. We get the statistics. The average answer, the average agreement in the slow speech condition is 7. The average in the fast speech condition is 10. Okay? Wow, we got more agreement in the fast speech condition, just as we predicted, than we got in the slow speech condition. Well, not quite ready to write home in celebration, okay, that we confirmed our hypothesis. It's possible that this difference, okay, this 3-point difference on a 15-point scale, okay, not a trivial difference. In fact, these guys are on the sort of the left side of neutral, and these guys are kind of modestly agreeing, okay, at least numerically. We'd have to do statistical tests to determine the extent to which this difference is trustworthy, okay. That's what we call statistical significance, because it's conceivable that, by chance alone, our random assignment isn't completely perfect. It is random. There's going to be some error, okay? There are other sources of possible error, so it could be that this difference is just a chance fluctuation. It's like my dividing the class in half and giving you the first exam, and I find that I just randomly divided the class. There were a few points difference on average between one half of the class and the other half of the class. Okay, that's going to happen just by chance alone. Okay, so did this happen just by chance alone? So there are statistical procedures that are used, okay, that tell us the extent to which we can trust this difference, that the difference is statistically significant. What we want to know is, what's the probability that we could get a difference, 3 points, okay, on this scale of that size, okay, by chance alone, okay, by chance alone, associated with something not being completely random and standardized above, okay? If the statistical test usually result in what's called a p-value, and you've probably heard the expression p less than 0.05. Okay, well, if you get to p less than 0.05, we consider the difference significant. P less than 0.05 means that the chances are less than 5% or 1 in 20, okay, that this difference could be due to chance alone. Okay, if we can be that confident, the chances are less than 5 in 100, less than 1 in 20, okay, that the difference is a product of chance, then we're going to conclude that it's a significant, trustworthy difference. That if we repeated this study, we'd get a significant result, okay, because the odds that it's just chance are that low. Okay, that's usually the cutoff point, 0.05. Okay, so let's say we do the test, and hey, we get a significant difference. Okay, the difference is significant. This is more agreement statistically than this. What does that mean? It doesn't mean it's a big effect. Okay, it doesn't mean it's necessarily an important effect. Okay, what it means is that it's a trustworthy result. Okay, it's a reliable result, one that we can trust is not just a chance fluctuation. So we can conclude from this study that yes, indeed, in this particular study, faster speech caused more agreement. Now I say, well, how can you say that we have demonstrated with a high level of certainty that the fast speech is the cause of the greater agreement? Well, we can because of the logic of experimentation. Everything, think about it, everything is the same. Random samples, all the variables controlled, same measure, everything the same speech, same speaker, same words, same conditions, same headphones, same recording, same volume, everything's the same. The only thing that differs between these two samples of people, okay, participants, is that these guys got the slow speech, these guys got the fast speech. That's the only thing that differs. Before we measure the dependent variable, and we have a difference in the dependent variable, then ergo, okay, the difference must be due to the differences in speech rate. And hence, we have cause and effect, okay? Speech rate causes differences in agreement, okay? The logic of the experimental method, okay? Now, we obviously want to do other studies. We'd want to do more with this. One swallow doesn't make a summer, as the saying goes. So this would have to be replicated. We'd want to do more complex experiments in different settings and look at different variables and how they interplay. We'll talk about that all in a little bit. But the basic experimental logic is illustrated kind of nicely with this simple experiment. And there are other experiments to talk about that are talked about in your textbook, which illustrates similar kinds of points. Okay, now what we're going to do in the next presentation, we're going to get to more complicated studies, which will allow us to revisit this and see how in the science we build on the finding and see, well, when is it true, when is it not, and so on and so forth. Okay, so I will leave that to the next the third and final narration in this series. Okay. By the way, when we get to the next one, don't be thrown off when I use the term, as we were talking about last Thursday, that the third is is a narration that was made in a previous semester. So I made the mistake of actually sort of mentioning the date, which is one doesn't do if one's going to use it repeatedly. But it is the right one, and don't worry, there was no last Thursday lecture. Okay, we'll see you, or we'll talk to you in the next narration.